So good morning. So this time we are going to continue with our discussion on the lesson 4 and 5 of the course software engineering. So I will share our discussion on my screen. Okay, so we have here already the lesson 4 or the lecture 4 titled incremental models, because we already through with the lesson or the lecture 1, 2, and 3 up to the waterfall model. So as discussed last Monday, the major drawbacks of the waterfall model are due to the fact that the entire product is developed and delivered to the client in one package. So if you are working with a system, or if you are working with a software, see to it that you deliver the entire product. Okay, after you implement, you need to deliver it to the client in a package. So, or we would say, dapat tanan that you include in your system will be delivered to the client or to the user or to the owner. Because if not, so this could result in a delayed feedback from the client, because they need to know the entire content of your system. So if not, so they could not give feedback of what you are creating. So because of the long elapsed time, a huge new investment of time and money may be required to fix any errors of omission or commission, or this also to accommodate any new requirements cropping up during this period. Because if they will encounter some problems with that, so you need to fix it, and it requires also effort, time, and money. So with this, may render the product as unusable. So hindi magamit. So incremental model may be used to overcome these issues. So this includes already the what we call incremental model. So in the incremental models, as opposed to the waterfall model that we used, actually, the product is partitioned into smaller pieces, which are then built and delivered to the client in increments at regular intervals. So what you're going to do is, instead of delivering it in one package, you can arrange it into a small pieces. Just like, for example, module 1, module 2, up to, for example, fifth module, or that would be the last, okay, included in your software, not as in a one package. So that is how we include a what we call incremental model. So dapat you have there a step-by-step process. Okay, so this partition into a smaller pieces, which are then built and delivered to the client in increments at a regular interval. So at least, if you are done with the module 1, send it to them, and then after you finish with module 2, at least they have already an idea how your software or your system is being processed. So since its piece is much smaller than the whole, it can be built and sent to the client quickly. Yes, it's this is one of the advantage, because it is put into a smaller pieces, so it's easy for you to send it to your clients. So this results in quick feedback from the client, and any requirement, related errors, or changes can be incorporated at a much lesser cost. At least if you use an incremental model or put it into smaller pieces, if they have noticed that there is a problem with the first model, at least it's easy for you to correct it, diba? Not as nga, you need to check everything or the whole of the system, and then you need to correct it. So if it is using incremental model, so it's easy for you to identify the error with that, okay, a piece of model. So it's since its piece is much smaller than the whole, or this results in quick feedback from the client, and any requirement related errors or changes can be incorporated at a much lesser cost. At the same time, agamay lang nga time or effort, ang mahuyang is because of that. Okay, so it is therefore less traumatic as compared to the waterfall model. So it also requires a smaller capital outlay and a yield rapid return on investment. Kaya kung gamay man to, using incremental model, so last mag-correct, and then you only it only requires a smaller amount of money. But then if it is a bigger one, so it includes a bigger amount. So if it is small, so you have there the smaller capital. So these are the interpretation of the incremental model. You have there the requirements phase. So in the requirements phase, you need to identify what are the requirements before you conduct with or you create or develop your system. You have there the specification phase. What would be included in your system? What would be the features? And then the architectural design. So what would be ano ang itsura ng inyong software? Ano ang pagplastar? Okay? And then for each build, perform a detailed design, implementation, and integration. So generally, you implement or integrate, you need to test the running of your system. And then after that, you're going to deliver it to your client. Okay. And then, but after the testing, after the integration, you need to have a maintenance phase. So who will maintain the system? Okay. So that's the time that if you're going to deliver it to the client, so see to it that your system is running and there is somebody who will maintain that. Okay. So however, this model needs an open architecture to allow integration of subsequent builds to yield the bigger product. And a number of variations are used in object-oriented life cycle models. So this will be the continuation later on regarding the object-oriented life cycle model. So if we have the object-oriented programming, still we have the life cycle of it. So there are two fundamental approaches to the incremental development. So in the first case, the requirements, specifications, and architectural design for the whole product are completed before implementation of the various builds commences. Yes. So before you implement it, see to it that your system is running, and then your system is also complete. Okay, because that is the requirements of our clients. Okay, to continue, so in a more risky version, once the user requirements have been elicited, the specifications of the first build are drawn up. So when this has been completed, the specification team will or turns to the specifications of the second build, while the design team designs the first build, and thus the various builds are constructed in parallel. So with each team make use of the information gained in all the previous builds. If you have noticed here, so the same, even though we use here the build 1 to 3, but the process is the same. You start with specification, design, implementation, and then integration, and deliver it to the client. So take note, class, that if you are working with the thesis, see to it that you are going to implement that kind of software or the system so that magamit gid kang inyong client. Hindi man pwede nga you create or you make your own title, you develop the system, but then hindi magamit. So it's useless. So much better if you have the problem that can solve, that create a solution to the problem of that establishment or an organization. So this approach incurs the risks that the resulting build will not fit together and hence requires careful monitoring. So dapat it depends kay, for example, if the client will use the system only for a year, so no need of monitoring. But if they are still using that kind of system for their business or for their establishment, So you need to monitor it. So if your system is still running or not. So rapid application development, or what we call RAD. So this RAD is another form of incremental model. So this is included in incremental model. It is a high-speed adaptation of the linear sequential model in which fully functional system in a very short time, 2 to 3 months, because this model is only applicable in the projects where requirements are well understood and project scope is constrained. So because of this reason, it is used primarily for information system, especially if your title is about the information system of the students of for example, Tibiao Central School. So you can use this RAD because the scope is constrained and the project requirements is well understood, because it's easy identifying the data of your students, of the students of Tibia Central School. Okay. So synchronized and stabilized model. So this is yet another form of incremental model adopted by Microsoft. So in this model, during the requirements analysis, interviews of potential customers are conducted and requirements document is developed. So once this requirements has been captured, specifications are drawn up. So the project is then divided into 3 or 4 builds. So each build is carried out by small teams working in parallel. At the end of each day, the code is synchronized, test, and debug. And at the end of the build, it is stabilized by freezing the build and removing any remaining defects. So take note that if you are working with the system, working with the codes or the pseudocode, see to it that you encounter some problems. So that is why you need to test or debug your source code. Okay. We have here the spiral model. So this model was developed by Barry Boehm. The main idea of this model is to avert risk, as there is always an element of risk in development of the software. Yes, you need to take a risks when you are working with this. Kaya dapat you are always positive when you're working or trying your best to work with your software. Kaya dapat you are a strong person, that you will do everything. You need to take a risks. You need to try everything so that mag-work out ang imong system. Okay, if you are not taking the risks, how could you come up with a very good presentation or a very good software with lagi na kinahanglan kang inyong client? So it is simplified form. The spiral model is waterfall model plus risk analysis. So in this case, each stage is preceded by identification of alternatives and risk analysis, and is then followed by evaluation and planning for the next phase. So if risks cannot be resolved, project is immediately terminated. So this is depicted in the following diagram. So you can see here the risk analysis. This includes the rapid prototype, specification, design, and implementation. Take note that if you are working with a system, kaliwat-liwat lang tayo na class, wherein you always start with the problem, the requirement specification, di ba? And at the end is the implementation, that you need to implement your system. So as can be seen, a spiral model has 2 dimensions. Radial dimension represents the cumulative cost to date, and angular dimension represents the progress through the spiral. So each phase begins by determining objectives of that phase, and each phase, a new process model may be followed. Just like in every title and every, or before you create with your software, you need to know first your objective is to, for example, to create a system that could blah, blah, blah. Okay? So you need to identify what would be the objectives of that. So mas nami plus if you are working with your thesis nga wala pa wala naga-exist, kay at least later on pwede natin ta na mapa-copyright or mapa-patent or mapa-UM. So much better if you will be the one or kamo ang first giba lang nga nag-create with that kind of system. Okay, much better. So a full version of the spiral model is shown here. So we have here the following. So you can read what is included in the spiral model. So the main strength of the spiral model comes from the fact that it's very sensitive to the risks. Because of the spiral nature of development, it is easy to judge how much to test, and there is no distinction between development and maintenance. So if you develop, this includes maintenance and implementation. It, however, can only be used for large-scale software development, and that too for internal or in-house software only. Okay, so we have here that determine objectives, alternatives, and constraints, identify and resolve risks, plan next phase, develop and verify next level of product. So you should not stop with what you are gathering data from your clients. So if you can add more, or if you can ask other people to help you in working with your software much better. Okay, so that is for the incremental model on the lesson 4. So we have here the last part for the lecture 5, that is object-oriented life cycle model. So before we have what we call the SDLC, or the System Development Life Cycle, but now we have here the object-oriented life cycle. So this appreciates the need for iteration within and between phases. Kay basta magamba kita class nga model, there are phases that you need to follow. So there are a number of these models. All of these models incorporate some form of iteration, parallelism, and incremental development. So let's start with extreme programming. Masama ba kita nga working with thesis, working with capstone, working with system? It includes programming. So in this approach, user requirements are captured through stories, which are the scenarios presenting the features needed by the client. So if you are presenting your title, or even in the pre-oral defense, so your panel will ask you what would be the features of your system. For example, or what would be the difference of your system. For example, if there is a existing system, ano ang kinalain kang inyong system compare sa anda nga system. Okay? What is the strength? Paano nimo mahambal that your system is unique? So ano ang kinalainan da? So you need to give your reason about your system. Okay? So estimate for duration and cost of each story is then carried out. Stories for the next build are selected. Then each build is divided into tasks. So test cases for tasks are drawn up first before and development, and continuous testing is performed throughout the development process. Mabalik ang development process. So dyan na dapat naka-develop na kamo, nakamatamat na kamo. For example, create with your system. Dyan na bala nakasilang 70% or 80% of your system is already running. So we have here, start with release planning, iteration, and then acceptance tests. So in release planning, you have there the architectural spike. So dyan ang masilid ang mga features ninyo. User stories na ano ang say user stories, di ba, you need to, every time you work with that, you need to gather data from the user or from the client. So ano ang ginambal nanda? So you need to state that. So ano ang mga problema na encounter nanda? And then iteration, you need to iterate it. And the last is acceptance tests. Okay, so if the client will accept it, it means you have nadamot ninyo ang gusto ng mata mo because they accept it. Okay, so one very important feature of extreme programming is the concept of pair programming. So in this, a team of 2 developers develop the software, working in team as a pair for to the extent that they even share a single computer. That is why in this time, for the student, before they graduate, they need to submit a thesis, and that is done by group. So 3 members per group, not as that individual, because it's also costs, di ba? Costly man nga, kung ikaw lang sara, so bakal man na magasto mo. So that is why we limit to 3 students. So in extreme programming model, computers are put in center of large room lined with cubicles, and client representative is always present. So dapat every time you have your presentation, so dapat ang client is always there, always present while you are discussing to the panel your system. So one very important restriction imposed in the model is that no team is allowed to work overtime for 2 successive weeks. So XP has some successes. So it is good when requirements are vague or changing and the overall scope of the project is limited. It is however too soon to evaluate XP. So amo na if you are already using extreme programming, if rapid na matapos ang imong nga system. For example, if kaya hindi mo ra ma-detect if you're just starting it. So next is we have the fountain model. So fountain model is another object-oriented life cycle model, and this is depicted in the following diagram. Actually, this is one of the examples that you'll be creating mga diagrams, how to work with that. Okay, what would be the process if you have this kind, you come up with this kind of title, what is included with your system, okay? So we have your maintenance, further development, operations, implementation, and integration. Kita niyo class, even though we have different models, but still the word that they are using is always there. Okay, just like the maintenance, implementation, integration, di ba? Object-oriented design. What lang but the presentation or the process is different. So this is the requirement for the fountain model. Next is RUP, or the Rational Unified Process. So this is very closely associated with UML and Cruchin's architectural models. In this model, a software product is designed and built in succession of incremental iterations. So it incorporates early testing and validation of design ideas and early risks mitigation. So in this rational unified process, this includes cycles, you have the phases, the iterations, and also the milestones. So this represents the figure depicting the RUP and taken from Cruchin's paper. So we have here the different phases: inception, elaboration, construction, and also transition. And so for the workflows, this includes the business modeling, the requirements, analysis and design, implementation, test, deployment, configuration and change management, project management, and the environment. So in inception, this includes what we call the initial, so medyo gamay lang gitana, up to the transition. Next is the comparison of life cycle model. So as discussed, each life cycle model has some strengths and weaknesses, yes. So these are summarized in the following table. So the same thing with how you work with your system. You should know the strength and the weakness of your system. So this includes the comparison of process models. So we have here the 3 that includes, you have there the process model, the strengths, and the weaknesses. Now, for the process model, so we have built and fixed model, the waterfall model, so dyan ka nakasilad, rapid prototyping model, incremental model. We have here the extreme programming, synchronized and stabilized model, spiral model, and then object-oriented model. So we have 2, 4, 6, 8 models that includes in the process model. So these are the strength and also their weaknesses. So dapat man natin, for example, if you are using a waterfall model, what would be the strength? Disciplined approach and document driven. So it means you know the process from the very beginning and at the end. So complete package na. But the weakness is delivered product may not meet client's need. Sa waterfall, may dyan nga you are may gindugang ka mo sa inyo bala nga system. So hindi gali gusto kang client ang amo to. So wala na meet ang need ng clients. Kaya gusto bitan ng client, very simple lang. Idugangan ninyo, gin-improve ninyo, which is hindi na magamit. Okay? So you should know what process you are going to use. Kaya mo ano nyo rin ka diagram or presentation with regards to the system you are creating. So the criteria to be used for deciding on a model include the organization, its management, skills of the employees, and the nature of the product. So take note of this. Okay? Kaya dapat involved with ang organization, the management, the skills of the employees, and the nature of the product. Okay? Dapat class, you are aware that we are after on the need of our client. Hindi ko nga ang atin tanang gusto nga matabo sa atin nga system amo ang masunod. No. It depends on our client. We have here next is the quality assurance and documentation. So not only as if you are done with your system, you need also to submit or to create a documentation. It may be noted that there is no separate question and answer or documentation phase. Kasi syempre the data client should evaluate your system if okay na siya, useful bala, it's easy to use, di ba? So quality assurance is an activity performed throughout software production. So it involves verification and validation. So i-validate gid ninyo ra class if you have already the system. Okay? So verification is performed at the end of its phase, whereas validation is performed before delivering the product to the client. Yes. So ipa-check ninyo sa panel, ipa-check ninyo rin sa may inyong advisor if okay na ang inyong system. Okay, maybe they have still a suggestion on how to improve that. So every phase must be fully documented before starting the next phase. So it is important to note that postponed documentation may never be completed as the responsible individual may leave. So documentation is important as the product is constantly changing. So we need the documentation to do this. So even though you have the system, you need to submit the documentation. At least bala makita nga not only as you focus on your system, but how you prepare with that, okay, based on your documentation. So we have here the phase on the same magyapon class, requirement definition, functional specification, we have the design, the coding, the integration or the maintenance. So for the documents, yan ang rapid prototype or requirements documents. Ano mga requirements? Just like you should know your objectives, you should know your the problem of that. And then for the specification documents, software product management plan, ano ginagamit ninyo, ano nga ang computer, di ba? And then architectural design or detailed design. So when we say detailed design, dyan ang makasulat ng your entity relationship diagram, the data flow diagram, the flow of your system. And then for the coding, you have there the source code. Siyempre, you need to work with your shadow code. Integration, source code, and then test cases. You need to test if your code is correct. And then maintenance, change record, or regression, or test cases. For QA, for quality assurance, rapid prototype, reviews, traceability, FS review, check the SPMP, So every time you have that kind of system or software, you need always to tests or to use integration testing, and then also acceptance testing. Okay, so I think this is included in our lesson 4 or lesson 5 of our topic today. Okay, so thank you everyone for your time and for listening.